Right, what I thought I'd do is just show you how I'm going to model up another design, because I really need to get practicing at these designs. It's really rainy and miserable outside, so I have got my K350 plans here, which I'm kind of using as a sort of a reference, and of course a cup of tea. So recording, yeah it is. Right, so this is what I'm going to do. I'm going to model up a 3 foot by 4 foot, because I'm basing this on the sort of K250 design, except I want it to be a 200-meter boat. So the first thing I'm going to do here is I'm going to switch to the PSUBS design calculator, and if you go for an unstiffened cylinder, so I'm just going to run, this is a totally just a round tube, and I'm going to go for 36 inches. My outside diameter, my length is 48 inches because it's all in imperial measurements, and my cylinder thickness, I've done this already, 0.394, that is 10 millimeters. Calculate, that gives, this is the maximum pressure ABS rules, so maximum pressure of 293 psi, 658 feet, so whatever that is, 658 feet in meters, don't really work in feet, 200 meters, right? So I think that according to this anyway, a 10 millimeter unstiffened cylinder would be good to 200 meters. So with stiffeners, it should be a complete beast. Now, what I want to do is just see how that actually works out within the simulation environment. In fact, what I'll do actually, let me just show you this. Let me show you this. I did one earlier here. Now, this is Jodie B. This is the pressure hull. This is exactly a totally correct model. And it says here, the applied loads may cause your design to deform permanently. I've applied a load here, a static pressure of, what was that? What did I give it? 131.4 psi, which is 9 bar. That's its maximum diving depth of 100 meters. Now, I've given it 9 bar, not 10, because there's 1 atmosphere of pressure inside, which this model isn't taking into account. I could have given this 146 psi and then put 1 psi pressure inside, but it's really awkward to select all the faces. And it's really annoying, this, because you can see there's just this little bit there. If I go to safety factor there, it's just on these little corners here. And I even smoothed the corners out, thinking it was a stress, the point was causing a stress riser, but those bits are giving it this failure mode. So I don't know whether, now this is a trusted design, so this should work. So I don't know whether this is what they call a singularity in the software. I honestly don't know, but I mean, look at it. The whole design is super safe. It's all green and blue, apart from that little bit. So I'm not sure what happened there. Right. Enough blabbing. Next one. So I'm going to go for a new design. Just to make it look a bit nicer. Right, simulation mode, static stress, Study materials. I'm going to change this. Now, I've been trying to find what the equivalent of ASTM A516 is, which is what Jodie B is made of. But that's not in the list, and I can't find something that translates to all of these other ones. So there is one here, steel for pressure vessels, so I'm going to use that one. So we don't need to simplify the model. I've chosen my materials, constraints, right. I'm going to go into settings and I'm going to say remove rigid bodies, or body modes. That means it doesn't need any constraints, so it's just floating about. And what else am I going to do? Loads, I suppose I better put some loads on. Pressure, targets. Right, let's go. So that, and there, and the one at the back, that, and that. Right, so I'm going to put in I want to put in a pressure of 200 meters, which is going to be 14.6 psi times 20 bar. But I'm only going to put in 19. I'll show you why. 14.6 times 19, 277.4 is what I'm going to put in. Oops, 277.4 psi of pressure. I've only put in 19 bar because there is going to be 1 bar of atmospheric pressure inside. Now I could apply another load and do pressure and start poking about, putting 1 bar or 14.6 psi inside, but there's not really any need, I don't think. Let's just have a look what other units we could have used there. Actually thinking about it, could we use? Oh, we can use bar, right? Let's just go for 19 bar. That's 190 meters. Got my pressures ready. Right, pre-check. It has a little moan about the structural constraints not being there, but let's do it. Let's see what it looks like. So it's done, and it's come up saying design is expected to bend prematurely, or no, permanently, or break under the current analysis criteria. So I don't know what I'm doing wrong, whether this is wrong. Let's just see where it shows it. Let's go to stress. Where is it moaning? It's that same point as it is in Jodie B. Right at that little corner there. So let's just look at the safety factor again. Is that a problem? I don't know. I don't know whether there's something wrong with the software or whether it genuinely will fail at that point. Because everything else is good, as we would expect, really, because this is a beast of a design. I mean, this is a complete monster. Might do a bit of research on the Autodesk forums, because people are generally quite helpful, and see what people say about that. This is where I do my diving in the summer. It's not very nice today.